So how many remember scientific notation? Did it last year? Okay. So it's mostly just a refresher. So the reason we use scientific notation is to express like really big numbers or really small numbers, especially in the science classes. I mean, we don't really have that much need to do it for the kind of examples we show in here, but in the science class, especially chemistry, I mean, they talk about this all the time. So scientific notation. So we're going to be using two terms. One, scientific notation, and then standard form just means not scientific notation. So if we want to write a really big number, instead of in standard form and scientific notation, right, the format is some number between 1 and 10 times 10 raised to an exponent. So in this standard form number, 2 million, that's 2 times 10 to the 6th. If you know, the decimal place is here. In order to put it in scientific notation, I have to move the decimal point over 1, 2, 3, 4, 5, 6. So that turns it into 2.0, which is in between 1 and 10. And since I moved to the left 6 decimal places, it's times 10 to the 6th. Usually the way I think of it is, if I'm making this number smaller, then I should be making that number getting bigger. They should change in opposite directions, right? So if I want to make this number 0.005 have that first number in between 1 and 10, that means I've got to move the decimal place over how many times? 1, 2, 3 times, okay? So then I've got 5, right? But since I moved to the right 3, since that number got bigger, going from 0.005 to 5, that number got bigger. That means the exponent should have got smaller. So 10 to the negative 3. It goes down while that went up. So this number should be between 1 and 10, right? If it gets more than 10, then you got to move another decimal place. All right, so we'll write these in scientific notation, right? How many decimal places am I going to have to move so that my first number here is in between 1 and 10? 7. Right, so you're going to move over 1, 2, 3, 4, 5, 6, 7. So 4.259. That in the right pen. 4.259 times 10 to the 7th. Right? And it is like written like that. Don't try to write the times like with the dot or parentheses or whatever. It's that big X for multiplication. That's scientific notation. Right. How many decimal places do I have to move so that this number starts with 1, 2, 3, 4, 5, right there. Right? So you don't have to go all the way to the right, right? We only make this first number between 1 and 10, move over 5. The second. So it's going to be 5.74 times big X for multiplication, 10 to the negative 5, right? Right? The first number, this got bigger, so that got smaller. Okay, you try it. Write that one in scientific notation. How many decimal places do you move? 5. So it looks like we went 1, 2, 3, 4, 5. So, okay, so the first number is 5.39, right? Now, what does that make the exponent on 10? Okay, times 10 to the positive 5. Okay, now let's go the opposite direction. What if you have a number in scientific notation and you want to write it in standard form? Right? So 10 to the 6th, so we want this number to go down, right? And so that number's got to go up. So we move over how many? 6 places. Equals 2, 1, 2, 3, 4, 5, 6. Is that enough?
Yeah.
I mean, you could put the commas in there. You could put the commas in there to mean like thousands and millions, and then that definitely looks like 6. What about the second one?
Go to the left.
To the left, since it's a negative exponent, we're going to go to the left 4. Okay, so it's going to start with a 0 point. And so how many zeros do I need in before the first one? 1, 2, 3, right? The fourth one is going to be the 1, and then 6, 8, 5. You know, if you're not sure, if you're more sure of what we did first than this, then just try to go backwards and see that it works, right? So 1, 2, 3, 4. That would give us the 1.685. Okay, try to write that one in standard form. Is this a really big number or a really small number?
Small.
It's a really small number, right? So this is going to be, what is it starting with? 0.0045. Does that look right? 1, 2, 3. So that's exactly right. Okay, operations with numbers, scientific notation. This is where it gets into
What?
properties of exponents, right? So if we have to multiply one number in scientific notation times another, I mean, first we're going to multiply 8.5 times 1.7. Right, it's going to be 8.5 times 1.7. And then it's going to be times 10 to the, and again, what do you do with exponents when you're multiplying? Right, it's the same base, 10. So you should add them. So it should be 10 to the 2 plus 6 is 8. Okay, now what is 8.5 times 1.7?
14.45.
14.45?
Yep.
Okay, but now that first number is not in between 1 and 10. So what do I have to do?
Where is this 10 point?
I'm going to have to move this decimal point over 1 to the left. And so what am I going to do to the exponent? Okay? You're going to add 1, right? Because when I move the decimal place over here, am I making that number bigger or smaller? It's getting smaller, so that means that gets bigger, right, to compensate. Because moving the decimal place over, going from 14 to 1.4, that number just got smaller, so that number gets bigger, right? That's the way you want to think of it. 1.445 times 10 to the 9th. Okay. Okay, how about if you're squaring? We're going to square. What do we usually do with the exponent, which is outside parentheses? You distribute it. So we're going to distribute that too. Right? We're going to make this, right? This 2 is going to come inside on that, and it's going to come in on that. So now we've got 1.5. I don't really need parentheses, so I'll put squared. And then what do we do with these here when you raise a power to a power? So multiply. So that's negative 6. Okay, now what is 1.5 squared? 2.25. Okay. Now, do we need to move the decimal point? No, that's yeah, this number is already between 1 and 10, so we're good with that. Okay, how about dividing? And we're going to have to divide these two numbers. And then 10 to the fourth over 10 to the negative 3, what do you do with the exponents? So subtract, right? Properties of exponents. That's why this follows properties of exponents. Okay, so I'm going to write it like this. This is 1.2 divided by 1.6 times 10 to the, what is 4 minus negative 3? Positive 7. Okay, what is 1.2 divided by 1.6? 0.75. Okay, so it's 0.75 times 10 to the 7th. Okay, do we have to do any last minute adjustments? Yeah, that 0.75 is not between 1 and 10. So we're gonna move over 1 to the right. That's gonna give us 7.5. What do we do with the exponent? Right? Because that first number got bigger, then the exponent's got to get smaller. 10 to the 6. You good? Okay. Okay, last one. Last slide. You try.
No.
What'd you get on the first one?
9.2 times 10 to the
Okay, so first you distribute, right? And that'll give us 1.3 squared times 10 to the negative 10. And 1.3 squared is 1.69. How about the second one? Right, so first I've got to divide these two. 4.5 over 1.5. Right, and that's going to be times 10 to the, subtract exponents, what do you get? 7. So this is 3 times 10 to the 7th. I think the main point of this lesson is just tying the properties of exponents to this. Because we probably won't see too much scientific notation. But when you get to chemistry, for sure, you know, I mean, they're all over that. Compiti.